This 188-ton tank was Germany's biggest mistake. May 1943. Adolf Hitler stands in front of a wooden mock-up at the Porsche facility, staring up at something that defies belief. It's a tank. But calling it a tank is like calling a cathedral a house. This thing weighs 188 tons, 4 times heavier than any Allied tank in existence. Its armor is so thick that nothing on Earth can penetrate it. Its gun can destroy any enemy vehicle from over 2 miles away. Hitler is ecstatic. He orders 150 of them built immediately. Fast forward 2 years. Germany is collapsing. Fuel is almost non-existent. Factories are bombed daily. Bridges are being blown up across Europe. And this monster tank, the Panzer VIII Maus, the heaviest fully enclosed armored vehicle ever built, sits uselessly because it's too heavy to cross a single bridge, too slow to reach any battlefield, and drinks fuel like a battleship. Only 2 prototypes were ever completed. Neither fired a shot in combat. This is the story of how Hitler's ego and engineering brilliance combined to create the most expensive paperweight in military history. Early 1942. Germany's situation is deteriorating rapidly. The invasion of the Soviet Union has stalled. American industry is ramping up. German commanders are requesting more Panzer VIIIs and Panthers, proven, effective medium tanks that can be mass-produced. They're begging for quantity over quality. Hitler ignores them completely, because Hitler has just learned that the Soviets are fielding the K-1, a heavy tank with thick armor. The Americans are developing the M26 Pershing. Stalin himself has ordered the JS-2, a 45-ton heavy tank named in his honor, and Hitler cannot tolerate the idea that anyone else might have bigger, heavier, more powerful tanks than Germany. This is crucial to understand. By 1942, Germany has already lost the strategic initiative. They're fighting a defensive war on multiple fronts. What they desperately need is thousands of reliable medium tanks, mobile tank destroyers, and fighter aircraft to protect their factories. What Hitler demands instead is a super-heavy breakthrough tank that's indestructible. On March 5, 1942, 2 contracts are issued simultaneously. One goes to Krupp, the legendary armaments manufacturer. The other goes to Dr. Ferdinand Porsche, yes, that Porsche, who at this point in his career has designed exactly 0 successful military vehicles. His Tiger prototype lost the competition to Henschel. His designs are innovative but plagued by complexity and unreliability. Why would Hitler give Porsche this contract? Some historians believe it was compensation for past failures. Others suggest Hitler was drawn to Porsche's willingness to pursue radical, ambitious designs without questioning feasibility. Porsche promised Hitler the moon, and Hitler wanted to believe him. The initial specifications call for a 100-ton tank. Within months, that figure balloons to 188 tons. For comparison, the American Sherman weighs 33 tons. The Soviet T-34 weighs 26 tons. The German Tiger I, already considered absurdly heavy, weighs 57 tons. The Maus would be heavier than 3 Tigers combined. The engineering challenges are immediately apparent. How do you move 188 tons? How do you power it? Where do you get that much steel when Germany is already running short on raw materials? How do you transport it when German rail gauge has weight limits? How does it cross rivers when every bridge in Europe would collapse under it? Porsche's solution to the mobility problem is his signature electric transmission, a system where a massive internal combustion engine drives an electrical generator, which then powers electric motors connected to the tracks. No mechanical transmission. On paper, this provides smooth, stepless speed control and eliminates the complexity of gearboxes. In reality, it's a maintenance nightmare. The system is heavy, complex, and temperamental, but Hitler approves it. Work begins in earnest. The Maus takes shape on paper first. The specifications are staggering. Overall length, 10.2 meters, 33 feet. Width, 3.71 meters, just barely narrow enough to fit on German rail flat cars. Height, 3.63 meters, 12 feet tall. And that weight, 188 metric tons. That's 414,000 pounds of steel, armor, machinery, and ammunition. The armor is absurd by any standard. The hull front, 220 millimeters thick. The sides, up to 190 millimeters. The turret front, 240 millimeters. The gun mantlet, 250 millimeters. For context, the Tiger I's frontal armor is 100 millimeters. The Maus has more than double that thickness, and at better angles. Allied tank guns simply cannot penetrate it. Even the powerful British 17-pounder, which can defeat Tiger armor at range, would bounce harmlessly off the Maus. The armament matches the armor. The main gun is a 128mm KWK-44, the same weapon used in the Jagdtiger tank destroyer, one of the most powerful anti-tank guns of the war. It can penetrate 160 millimeters of armor at 2,000 meters. That means it can destroy any Allied tank. Sherman, Churchill, Pershing, even the later Soviet IS-2, from ranges exceeding 2 miles. Nothing the Allies field can touch the Maus at range, and the Maus can kill anything that moves. The secondary armament is a coaxial 75mm gun, the same caliber as the Sherman's main gun, mounted alongside the 128mm. This is for lighter targets and conserving the massive 128mm ammunition. There's also a 7.92mm machine gun for anti-aircraft defense. The ammunition capacity, 68 rounds for the 128mm, 100 rounds for the 75mm, and 1,000 rounds for the machine gun. The crew number 6, commander, gunner, 2 loaders, necessary because the 128mm shells are so heavy, driver, and radio operator. They're packed into a vehicle where the engine and generator occupy the entire rear 2/3 of the hull. There's no direct access from the driver's compartment to the turret. The fighting compartment is cramped despite the tank's enormous size. The power plant goes through multiple iterations. Initially, it's supposed to be a Daimler-Benz MB509 gasoline engine adapted from an aircraft engine, displacing 44.5 liters. Later prototypes use the MB517 diesel, producing around 1,200 horsepower. That sounds impressive until you do the math. 1,200 horsepower to move 188 tons gives you a power-to-weight ratio of 6.4 horsepower per ton. For comparison, the Sherman has 16 horsepower per ton. The T-34 has 19 horsepower per ton. Even the Tiger one has 13 horsepower per ton. The Maus is catastrophically underpowered. Maximum speed, 20 kilometers per hour on roads. Maybe. In testing, they struggle to reach 13 kilometers per hour. Off-road performance is abysmal. Fuel consumption is apocalyptic. The tank carries 4,200 liters of fuel and can travel maybe 160 kilometers on roads before running dry. Off-road range, 62 kilometers, less than 40 miles before it needs refueling. And then there's the bridge problem. The Maus is too heavy to cross any bridge in Europe. Period. The solution Porsche devises is genuinely insane. The Maus will ford rivers by driving underwater across the river bottom. The crew will breathe through a snorkel. The vehicle will be sealed against water ingress. And, here's the best part, a second Maus will remain on the near bank, connected by a cable, supplying electrical power to the submerged vehicle because the engine can't run underwater. This isn't science fiction. They actually designed and tested this system. The Maus can theoretically operate at depths up to 8 meters, 26 feet. Imagine being a crew member sealed inside 188 tons of steel, driving blind across a riverbed, hoping the snorkel doesn't fail and the cable doesn't disconnect. December 1943. The first prototype, V1, is assembled at Alket's factory in Berlin. It's completed without a turret because the turret isn't ready yet. Instead, they mount a weighted mock-up, a solid block of steel simulating the turret's weight. Even incomplete, the vehicle is staggering to behold. Testing begins immediately at the Kummersdorf proving grounds near Berlin, and the problems start immediately. The electric transmission is temperamental. The engine overheats. The tracks, specially designed over 1 meter wide each, break under the strain. The suspension struggles with the weight. Fuel consumption is even worse than predicted, but they continue. Repairs are made. Adjustments are implemented. By June 1944, 6 months later, the actual production turret with armament is fitted to V1. This turret weighs 55 tons by itself. It takes 6 German half-tracks, the largest half-track vehicles Germany built during the war, just to lift it. In March 1944, the second prototype, V2 is delivered. It incorporates improvements based on V1's testing, a better engine, new electric steering, improved running gear designed by Skoda. More testing follows. The Maus proves it can move, turn, and fire its weapons. The armor is genuinely impenetrable to any Allied weapon. But here's what they can't fix. It's catastrophically slow. It can't keep up with any other German armored vehicles. It can't maneuver tactically. It can't respond to threats quickly. In a fluid, mobile battle, which is what warfare has become by 1944, the Maus is a liability, not an asset. The fuel consumption means it needs constant resupply. But Germany's fuel situation by 1944 is desperate. Refineries are being bombed. Supply lines are cut. The Wehrmacht is running out of fuel for the vehicles it already has. Introducing a tank that drinks fuel at battleship rates is insane. The manufacturing requirements are equally impossible. Each Maus requires massive amounts of high-grade steel. The armor plates have to be rolled, cut, milled, and welded with extraordinary precision. Each vehicle takes thousands of man-hours to produce. The factories are being bombed regularly by Allied air forces. May 1943, when Hitler approved mass production and ordered 150 Maus tanks, seems like a lifetime ago. By mid-1944, reality has set in. Albert Speer, Minister of Armaments and War Production, is trying to rationalize German production. He's pushing for fewer types of vehicles, standardized parts, and higher production rates of proven designs. July 1944. Hitler's regime barely survives an assassination attempt. A week later, on July 27th, Hitler personally orders all work on the Maus to cease. Production is officially canceled. Krupp had 4 more hulls in various stages of completion. They're ordered to scrap them. All work stops in August 1944, but V1 and V2 still exist. And testing continues sporadically because engineers want to learn something from this disaster. April 1945. The Soviet Red Army is advancing toward Berlin from the east. The war is effectively over. Germany's military is collapsing on all fronts. The Kummersdorf proving grounds, where both Maus prototypes are located, lies directly in the Soviet path. The German forces at Kummersdorf make a decision. They'll destroy the prototypes rather than let them fall into enemy hands. V2, the more complete vehicle with the fully armed turret, is positioned near a bunker. German engineers plant explosives in the engine compartment and the fighting compartment. They detonate. The explosion is massive. The ammunition stored under the turret magnifies the blast. The turret survives more or less intact, but the hull is wrecked. V1 doesn't reach the bunker area. Sources disagree on exactly what happened, but the vehicle is abandoned with less damage. When Soviet forces arrive, they find 2 destroyed Maus prototypes and several incomplete hulls and factories. The Soviet commander of armored and mechanized troops sees an opportunity. Here is the heaviest tank ever built, designed by one of Germany's most celebrated engineers, incorporating cutting-edge technology. Even destroyed, it's a treasure trove of intelligence. He orders the tanks recovered and studied. Soviet engineers assess the damage. V2's turret is intact. V1's hull is in better condition than V2's hull. The solution is obvious. Mate V1's hull with V2's turret. Create a single complete vehicle from 2 wrecks. They use 6 captured German SDKFZ, 9 half-tracks to pull the 55-ton turret off the destroyed V2 hull. It's a massive undertaking, but they succeed. The hybrid Maus, V1's hull with V2's turret, is completed in Germany, then transported to the Soviet Union. A special rail car has to be used because of the weight. The journey must have been a logistical nightmare, avoiding tunnels and bridges that couldn't support the load. The Soviets conduct firing tests. They shoot at it with their own weapons to see what it takes to damage the armor. At least 7 hits are recorded on the side armor, including tests with shape-charge anti-tank grenades. The glacis front is hit at least 10 times with various weapons. The armor holds up remarkably well, confirming that the Maus is indeed nearly impervious to conventional anti-tank weapons of the era. But the Soviets reached the same conclusion the Germans did. This tank is a dead end. It's too heavy, too slow, too fuel-hungry, and too expensive. The future of armored warfare lies in mobile main battle tanks that balance firepower, protection, and mobility. Vehicles like the T-54, which will become one of the most successful tank designs in history. The Maus is eventually sent to the Kubinka Tank Museum outside Moscow, where it remains to this day. It's been stripped of its internals, the engine, transmission, motors, all gone. It's an empty armored shell, a monument to engineering ambition and strategic folly. Let's talk about what the Maus actually cost Germany, because the numbers are staggering even if most aren't publicly recorded. We know that only 2 complete hulls and 1 turret were finished before cancellation, but Krupp had 30 hulls in various stages of completion after the August 1943 bombing raid. 4 more were being built when Hitler canceled the program in July 1944. Think about the resources that went into this. Each Maus hull required massive steel armor plates, up to 240 millimeters thick, that had to be rolled, milled, cut, and welded. The side armor alone consumed tons of high-grade steel. Krupp engineers struggled with how to manufacture it because milling out 4.5 tons of steel from each side plate was wasteful and time-consuming. The turret was even more complex. That 55-ton rotating structure with 250 millimeter armor on the mantle required precision manufacturing. The turret ring diameter was nearly 3 meters. The gun mounting system had to handle the recoil forces of a 128 millimeter cannon. This wasn't mass production. This was custom craftsmanship on an industrial scale. Now multiply that by the workers required. Krupp estimated they would need an additional 200 workers per month just to resume Maus production, and at that rate, they could only produce 2 vehicles per month, 1/5 of the originally planned rate of 10 per month. What could those resources have produced instead? Hundreds of Panzer IVs, dozens of Panthers, more Sturmgeschütz 3 assault guns, which were actually winning battles on the Eastern Front, more anti-tank guns, more ammunition, more trucks to keep supply lines running. But here's the really damning part. By 1943, Germany's strategic situation required defensive weapons. They needed fighter aircraft to stop Allied bombers from destroying their factories. They needed anti-aircraft guns. They needed mobile tank destroyers that could ambush Soviet armor and retreat. They needed cheap, reliable vehicles that could be produced in quantity. The Maus was the opposite of everything Germany needed. It was an offensive breakthrough weapon designed for a war of conquest. By the time the first prototype rolled out in December 1943, Germany was fighting for survival on its own territory. The whole concept was obsolete before the first prototype was completed. And fuel. The fuel issue cannot be overstated. By 1944, Germany's synthetic fuel production is under constant attack. The Wehrmacht is rationing fuel desperately. Tanks are being abandoned, not because they're damaged, but because there's no fuel to move them. Into this situation, Hitler approved development of a vehicle that consumes fuel at a rate that would make a naval destroyer blush. Hitler ordered 150 Maus tanks in May 1943. Let's imagine they'd actually built them. That's 28,200 tons of armor, machinery, and weaponry. The fuel requirements to operate them, even for a single month, would be astronomical. The manufacturing capacity would have absorbed resources from dozens of other programs. The result? Germany's military would have been weaker, not stronger. The Maus represents something deeper than just a failed tank design. It's a perfect example of how Nazi Germany's leadership fundamentally misunderstood modern warfare by 1943 to 1944. Hitler's decision-making process was driven by ego, prestige, and technological fetishism rather than strategic necessity. Look at the pattern. Germany produced jet fighters, the Me-262, but Hitler initially insisted they be modified as bombers rather than interceptors, despite the desperate need for air defense. Germany developed the V-2 rocket, which consumed enormous resources and achieved essentially nothing strategically. Germany designed the Type 21 submarine with revolutionary technology, but too late and in too few numbers to matter. The Maus fits perfectly into this pattern. It's a wonder weapon, a propaganda tool designed to intimidate and impress. When Hitler stood before that wooden mock-up in May 1943, He wasn't thinking about tactical employment or strategic value. He was thinking about prestige, about having the biggest, heaviest, most powerful tank in the world, about proving German engineering superiority. Meanwhile, the Soviets were churning out T-34s by the thousands. The Americans were producing Shermans at a rate Germany couldn't match with all its tank types combined. Both nations had figured out that modern mechanized warfare requires quantity and reliability, not individual invincibility. There's a reason the Sherman succeeded despite being inferior to German tanks in armor and firepower. It was reliable. It could be repaired in the field with basic tools. Parts were standardized and available. It could be transported easily by ship and rail. It could actually reach the battlefield and fight. 5 Shermans could be produced for the resources needed for one Tiger. And 5 Shermans working together could defeat a Tiger through combined tactics. The Maus takes this German obsession with individual vehicle superiority to its logical, absurd conclusion. Create a tank so powerful and so heavily armored that nothing can stop it. Make it invincible. And in doing so, create something so heavy it can't cross bridges, so slow it can't maneuver, so fuel-hungry it can't operate, and so expensive that only 2 can be built. Some German officers saw this clearly. Heinz Guderian, one of the fathers of German armored warfare doctrine, was skeptical of the heavy tank obsession. He wanted more Panthers and Panzer IVs. He understood that mobility and numbers win wars, not individual vehicles. But Hitler overruled him repeatedly. The tragedy is that German engineers were brilliant. The technology in the Maus was genuinely innovative. The electric transmission concept, while flawed, was ahead of its time. The armor scheme was revolutionary. The gun was devastating. In another context with different priorities and resources, these innovations could have been directed toward practical, effective weapons. Instead, they were poured into a vehicle that served no useful purpose except to satisfy Hitler's ego and drain resources from programs that might have actually extended the war. April 21, 1945. The Red Army reaches Kummersdorf. German forces hastily destroy the V2 prototype. The Maus program ends not with a bang, but with a whimper. Engineers blowing up their own creation to prevent capture. Today, the sole surviving Maus sits in the Kubinka Tank Museum, a tourist attraction and historical curiosity. It stands as a monument to engineering excellence wasted on strategic stupidity. Visitors walk around it, marveling at its size. 188 tons, the heaviest tank ever built, and utterly, completely useless. The lessons of the Maus echo through military history. Bigger isn't better. More expensive isn't more effective. Intimidating on paper doesn't mean successful in practice. Weapons must match strategic needs, not personal ambitions. Resources are finite, and every choice has an opportunity cost. Germany didn't lose World War II because the Maus failed. Germany was already losing, but the Maus symbolizes why they lost, because leadership made decisions based on ego instead of reality, because they valued prestige over practicality, because they chased wonder weapons instead of producing effective military equipment in necessary quantities. Think about what those resources could have produced. Every ton of steel that went into the Maus could have armored dozens of Sturmgeschütz assault guns. Every engineer hour spent solving the Maus's problems could have improved existing designs. Every mark spent on this boondoggle could have gone toward fighter aircraft, anti-aircraft guns, trucks, fuel, ammunition. Things Germany desperately needed. The United States produced over 49,000 Sherman tanks during World War II. The Soviet Union produced over 57,000 T-34s. Germany's total tank production for the entire war, all types combined, was under 50,000 vehicles. And within that total, they wasted precious resources on projects like the Maus that contributed nothing to their war effort. This is what happens when ego drives engineering, when leaders demand the impossible and engineers say yes instead of no, when military procurement becomes about prestige instead of effectiveness, when nations prioritize making a statement over winning wars. The Maus could destroy any Allied tank from over 2 miles away. Its armor was impenetrable to any weapon of its era. It was a genuine engineering marvel, and it changed absolutely nothing about the outcome of World War II except to make Germany's defeat slightly quicker by diverting resources from useful projects. That's the real legacy of the Maus. Not as a tank, not as a weapon, but as a cautionary tale about what happens when military power becomes disconnected from strategic reality. When leaders chase fantasies instead of addressing facts. When the biggest mistake isn't building something that doesn't work, it's building something that works perfectly, but serves no useful purpose. If this deep dive into one of history's most fascinating military failures grabbed your attention, that like helps others discover these stories. Subscribe for more explorations of weapons that looked incredible on paper but failed in reality, or sometimes succeeded despite all odds. What other World War II engineering disasters should I investigate? The Type 21 U-boat that arrived too late? The He-177 bomber that kept catching fire? The V-2 rocket that cost more than the Manhattan Project but achieved nothing strategic? Drop your suggestions below. Every comment shapes future content. Thanks for watching, and I'll see you in the next historical miscalculation.